Right. So hello, welcome to my talk. It's going to be a live coding talk. I'm going to try to live code a testing library in Ruby, starting from scratch. I've set up Vim with a shortcut. Every time I press enter, I execute the current file, which is a Ruby script, and we get the output at the bottom so that we can iterate quickly. I'm going to leave something like done at the bottom so that we make sure that we have some output, that everything is working correctly. So the first thing, the basis of the basis of any testing framework is some way to assert something. So we want an assert function, right? Something that can do this. Well, now it's not defined. Let's define assert. Oops. Wrong number of arguments. It takes one argument. Let's call it the condition because, yeah, okay. It does nothing. Let's try to force the case where it should fail. It doesn't fail either. So this is interesting how to check that it fails. You wrap the thing in a block. You rescue an exception. So I'm going to call this assertion failure and define an error class. So assertion failure is a standard error. And so we say that by default we haven't raised. If we catch this assertion failure, we have raised. And we raise unless we have not raised, if that makes sense. Raised, nothing raised, unless raised. Then we need to define this thing here. Right, so it says nothing raised because we haven't raised anything. By the way, feel free to interrupt me at any time if something is not clear or slightly weird.
So
right.
This is the full-on test first approach.
Yeah.
From scratch.
It doesn't have to be, but you know, the smaller the iterations, the more confidence we get in that it works. Because if you're basing well, of course, this is not going to production, but if you're going to use this for testing other code, you need to have absolute reliability. And one way is to really manually test and then automate the manual testing of, automate the testing of the library itself. Right, so here we'll raise assertion failure unless condition. And we made it pass. So to give another example, should be good. Like if here we say assertion failure, right? And now that we have assert, we can define assert equal, for instance. That's because instead of having like this, it's much nicer to have a specific function that says that well, this will fail, but let's say start with foo equals foo. It doesn't exist. We define it. Okay. It takes two arguments, the expected value and the actual value. And then we implement it in terms of assert itself. So we say expected. Right. Oops. So let's see it fail again to verify that we are doing everything correctly. Okay. One thing that's not cool is here we have the generic message that there's some exception somewhere in the code. So we can add that. We can do this here as a message, which by default can be assertion failed. And I'm adding a default because I don't want to specify a message for the failure case every time. And what we do is you can print the you can have the message to go along with your exception, right? I'm going to rewrite this a bit nicer. Okay, and then we're good. And then for this one, we can define a message saying something like expected, but got this one. And we pass it in here. And yeah, expected foo got bar. Something that is not nice is it's hard to distinguish between the literal values and error text. So actually one thing we can do is we can have a human representation of the values, right? And now we have with quotes. Right. Let me quickly check my notes. Right, and since again we want to see that this fails, well, we have two cases. We have a case that doesn't fail and a case that fails. But instead of implementing this thing again, this logic, I'm going to extract it in a method of itself, which I'll call assert. Too many S's. Asserts error, which will take a block and well. So what do we do? Oops. We yield here, meaning that now we can replace this thing by just assert error and here again assert error. And we're good. Alright so far? Okay, one thing we have so far is that by default we have no output. We have this done here, but we're especially for those cases, since the what makes noise is the failure but not the success, we have no idea if this test is still executing. So one thing we might want to do is add some output, but before we get there, I want to group the assertions into test cases, because maybe you want several assertions pertaining to the same concept. So I'm just going to define functions. So let's call them test assert for now, because one tests the assert function. Okay, and test assert equal. Oops. Yeah, this talk has plenty of me using Vim incorrect lore. Right, so print, I'll just print a dot. So if we see a dot, it's been executed. Here it's not being executed because I haven't called them yet. So oops. Assert, test assert equal, and test assert. Okay, 2 dots, and we're good. Yeah, cool. This of course is a bit tedious. The whole point of the framework is that it executes all your tests. You don't want to write all these boilerplates. So what we're going to do is try to group the tests in a test suite, and there's several methods we can do that. But the most straightforward, I would say, in Ruby is just to put them in a class, because a class is a concept that already exists. It's like a natural part of Ruby. Everyone knows about it. And you get some nice properties. For instance, if here, since those are now functions or methods in a class, so let's say assertion tests. Since those are in a class, we get some benefits like not sharing state between the test cases. So for instance, if here I have A, well, let me do this first. I have A, right? But if here I accidentally use A, it says it's not there, meaning that if yeah, stuff like if here A is another value or whatever, there's no leakage between the tests. So this is kind of important. So anyway, we group them in a class, and then what we do is we instantiate, of course, and run them individually. So, oops. Yeah. Cool. We still have this, but we can do something here. There's a way in Ruby to get the methods defined in a class. I'll demonstrate this one quickly. So let's say I have a class foo, which defines method bar, and okay. So let's create a new foo. Okay. There's a thing called public method. It lists all the symbols, so all the messages that this foo responds to, and since it responds to way too much stuff, because some of it comes from object or other, so you know it's the whole hierarchy. You can get just the methods defined in the class itself. There's this argument in the docs, it's just called all, and it says when all is false, you get just the methods from the class itself. So here we have bar, we define bar, we don't get any of the other stuff. Right. So what we do is we enumerate those methods, and for each of them, so the suite has tests, I would say, and we just send it test. Does everyone understand what this does? This is basically, say, suite.test, but test is can be any of those values. This is an array of names. And so we use metaprogramming here to just execute each of them. Good so far? Right. But obviously we don't want to be doing this either. So we're going to first define a method here. No, let's define a generic class called test suite, and a test suite will be able to, no, sorry, before doing that, maybe we can just extract this in a function. So we define a function called run that takes a suite, does this, so we just have run.suite, still there. Now I want to move this into a class, so I have this test suite class. Okay, and we test suite.new.run, and we pass our suite of tests, which is this other class. This is a bit cumbersome, so we'll do a refactoring to not have to instantiate the classes that contain the tests. I'm just going to move this over here. Okay, so the first thing we do is we will change this thing to only run methods that start by test underscore. We can do this, well, since this is an array of names, we can use a regular expression to match everything that starts with test underscore, and we're still good. So the next thing we do is we make this suite a subclass of the test suite, and we can do this directly now. Okay, but it's a bit awkward to have to pass itself in the method here, so we'll have a step-by-step refactoring. We pass in self, so good. Here we did, oops. So now it's still running. Next thing is, well, since nobody is using this argument, how do we do this? Oh, right. No, the next part is we just use self implicitly, still going, and then we remove the argument altogether, and we're still good. Questions? Okay, and but so imagine if we had a class of other tests which also inherited from this. So we have who don't care about this. Maybe we just want to make sure we're running it. So we have. So now it's not running, and we need to do this again. Run. Yeah, now we have 3 test runnings. But this, again, we've just transformed from running methods, different functions to instantiating classes and running methods on them. So we would like to have a single entry point, and this entry point can just be a method, a class method on test suite called run. And to get there, we'll use again some Ruby features. We can keep an array of subclasses. So there's this callback called inherited. So whenever a class inherits from this test suite, this inherited class method gets called, and so what we can do is we can remember this. We can remember the class, and then we define another method that just iterates over the registered classes. Here we need to instantiate because instantiate because we just have the class itself. We don't have an object, an instance of that class, and then we call run, and so still good. Now we have them running twice, and we can just get rid of that, and we're good. Any questions here?
That was a bit fast. So
okay.
What happens? So why do I don't have to run?
So let's see. Here I have this, right? I have assertion tests inheriting from test suite, and when this happens, this code gets executed, and so we just keep track of all the subclasses of this one, and then we run, the one method that which is this one, which just traverses all the classes and executes the run method on these classes.
So this code is executed on definition time of the class, in a sense, when you define the class, not when you run anything.
This one is executed when you define yes.
Yeah, that's the step I didn't get.
Yeah.
So
Yeah, it's a callback. It's a
that's
callback.
mentally kind of weird. To think of compiling classes, right? Because that doesn't exist in other languages.
This way you can at runtime define more classes and this still gets added to this thing and get run.
There's inherited and callback invoked whenever a subclass of the current class is created.
Can't you just have those subclasses in another method?
Maybe, I don't know.
This one is pretty cool, but I would have
I
to find some kind of subclasses who have public methods and superclass and this kind of thing.
yeah.
I'm not sure if you have subclasses.
Yeah.
You don't need it, but
But
So
actually,
that you don't have to inherit the track.
yeah.
Yeah.
yeah. I don't know. And you have something similar for modules. You have included when it's included, you can execute some code, or when it's extended, or when a class gets extended by module.
Yeah, included rates you can think about.
Yeah. Let me check my notes again if we have some other cool stuff. Right. Okay. Oh yeah, one thing we get for free is, since now we have this structure where here we execute each test, we can have a setup and a tear down step. So this is the nomenclature in Minitest, but in our spec it's before and after. And right now it will fail because they don't exist, so we can just provide defaults. And since all these, since every class containing tests inherits from this superclass, they can just have the default, and if they want to do some setup or tear down, they can override them. And then another thing we can do is remove those pesky print statements from the individual tests. So we'll do a similar thing as before. We rescue assertion failure, and we print an F as in failed, and otherwise we just print a dot. So if this fails here, get the F instead. Okay, now we have too many dots, so just this one is plus. Okay, cool. Right, so this is the basis, and I have much more to show, but since the actual programming takes a while, I suggest I show you the result, kind of. I wrote a library like this last summer, and have the same structure in a way. So this is a library. I don't know how to. Maybe I don't need the. Right, so we have a test directory, so this tests the actual library, so it's testing itself. And this is a neat trick here with the auto run. So I don't know if you have, if you use Minitest, but in Minitest, so you can have basically a Ruby file. So Minitest demo. If you require Minitest auto run and have thanks, and have this. Now if I run this, it runs it's assuming it's a test file, and of course I have no test defined in there, but that's what it does. And this is not that hard to implement. So I have it in a separate file just to have this one include. So if you include the default library by default, you don't get the auto-run behavior, but with this you do get it. And this requires the main thing, and the magic is kind of here. So we have this this class level variable at exit registered, and this makes sure that we only register tests for execution once. So the magic is all here. This at exit hook will be at exit. Right, so at exit executes something before the program closes. So what Minitest does, and probably RSpec and others, what you do is you register all your tests, and you make sure that all of your production code is required before the tests are and everything like this. And then once you exit the program, you're sure that everything was defined, and then you can run the tests. And you get the same thing with, registering all the test suites and like the subclasses, all of this stuff. So it's pretty neat. So, well, right. So here I just called this one method, and it just does at exit run this. And run does something else. It parses some command line arguments and basically does what I did before. But instead of doing test suite.run at the end of the file, I can just require this auto-run module, library, and then it does it automatically. Another interesting thing is stack traces. In my example before, if I ran, so let's say this fails. So if this, but now I added the catch behavior. But the point is, if it fails, you get the whole stack trace, and you don't care about the library internals. You don't care about the testing library internals. Unless you're testing the library itself, but users don't care about that. So what you can do is, at the place where you actually output the message, you can filter the backtrace and remove all the lines that are in your library. There's a similar thing that happens in Minitest. It's a bit more complicated. I didn't understand all of the lines there because, I don't know, there's probably some edge cases. Probably if you use this in production, you get to see them and why you need to exclude more stuff. But basically what happens here is that if you get a failure, so I'm pretty sure I have some test cases. So if I have this, now I just get this one line instead of the whole stack trace. And as you can see, I'm testing the library using itself. So testing assertions, that's the same kind of stuff I showed before. I am doing a thing where I'm testing the output. So we want to see, for instance, a summary in the end that we have run that many assertions and we have that many failures and stuff like this. We want to test order, for instance. So I implemented a thing where you can pass command line flag to the file, and you define a seed, and then you can reproduce the test run. And I'm making sure that the ordering is correct. So how do you do the random order? You just where is it? You just shuffle the things, and I pass in either a new seed or you already get the existing seed that you passed in. Another interesting thing is I talked about. Let me close this one. I talked about how I'm testing. Well, this thing is testing itself, right? But there's a problem, and a problem I didn't realize would occur until I ran it. We did this thing where you would register a subclass when you inherit from the superclass, right? But my test suite contains test suites. So here I have this defined suite, which is just creating a subclass from this thing, and I need to add this thing and register. What happens is that this is a top level. This is a test suite, right? That's using this. But if inside there's a test suite that's only for test purposes, you get into an infinite loop situation where you're registering and registering and registering, and like since you register a thing inside, then it runs all the, and then yeah, and so I had to add this unregister thing, which just which would just remove the entry. So for those temporary suites that are anonymous, basically, we just want to register them once and register them using the primitives that are exposed in the internals. But we don't want them to be run by this thing. So once it's here, we have it, and it gets run, but this thing doesn't see it as a suite to be run. It's a bit, another interesting thing is this here with string.io. So in my file, I print dots and f's and a summary report at the end and so on. And how do you test console output? Well, you can have this IO object. So by default, it's standard out. And whenever you need to, for instance, do print or puts or whatever, you use this IO object. And well, it doesn't matter. It's also in the Rubies. It's pseudo IO, right? But I believe that so it implements all the same things that like the standard output or files implement. So you can just use this, pass this in the tests, and then make assertions on it. So for instance, here I'm asserting that. So first I convert the output to a string, because this output is a string IO object. Right, returns the underlying string object, and then I run the assertion on it. And here I'm using the assertion that I wrote myself. It also gets tricky here. What you do is, since I'm testing the output, like exactly what I show in the end of the report and how many tests run and so on, at first I can just count them and then run the test that actually asserts that those things are accounted for. And then as I add new tests, I can, okay, so I have this output from my own test suite, so that means it's fine. And then I've tested the basics of assertions and so on, so that's fine. And then you build upon it, and it's super fast. Because, I mean, first of all, I'm not requiring anything external, and then yeah, so I can reproduce this run. Yeah. So yeah, that's about it. I've skipped, for instance, one thing I skipped is well, test doubles you can just do yourselves. Stubs you can do yourself, kind of. Like one manual way of doing stubs is if you want to stub an instance, so you have your object, which is object new, you can define a method on this object, right, to have something, and this is a stub. Mocks, I don't know how to, well, I haven't thought about how to implement them, but yeah, not that complicated in a simple case, and then depending on what your needs are, you can get very here. But with mocks, you need to pay attention to verify that the function was called. So there's some metaprogramming there. Right. That's it for me. Do you have questions? Yep.
Do you care about the exit code? Like when a test fails, that you return it back to the system?
Maybe, maybe not. I'm not sure. Do you know how it's dollar?
Question. Echo.
Yeah. So, but it was 0. So here it's okay. And if we make something fail, no.
Good.
Okay. So
Just
that's a to do.
How big is the risk that you break the part in your testing library which identifies failures, and then you wouldn't see that fact anymore? Because you're blind to failures now, and so it would succeed, right?
I would say this you can track historically. So if let's say I wanted to use this, I would have it on continuous integration, and I would run each thing, right? And so, for instance, in the last run, I would say, it ran that many tests, and if for some reason the thing that fails doesn't report anymore, it probably means that it doesn't get output, right? There's no F if something fails. Or since the test that the output is correct is still there and I haven't modified it, if the functionality itself fails, well, either I see the failure or the output is not there anymore, and then suddenly, last time I had 35 tests, why do I only have 20 tests this time? For me, this is one way, but I haven't thought about it in more detail.
It's kind of mind-bending.
Yeah.
It's like,
by the way, I do recommend reading Minitest if you ever want to. It's about 1,500 lines, I think, but with all of its things. So Minitest has spec syntax and all of the other stuff, but the basics are very, very small as well. And this one, yeah, it's just 160 lines of code, and then some test code. So it's not that hard to implement. So I would never use this in production, but I kind of did it to prove myself that it's not that hard, and also it was fun.
you have an opinion on this whole thing about using more integration tests versus using more unit tests?
This thing is definitely made more for, well, actually I don't know. But to answer your question, it depends on what you're testing, I think. Here in the library itself, I wanted to do integration tests for the output, but it was a bit hard. I saw how Minitest does it. What they do is, since you can have different failure messages or different file names, what they do is they capture the output, same way with string.io, and then they change some characters and make them X's or something. And then you really get the whole output without caring about any of the internals. And then in the test itself, there's a string that says, this must look like this. And this is integration testing for me, because you don't have to do any of this thing I do here with setting up the reports and so on. Like, this is too much, too close to the internals. I would like to test this. But if I was writing another kind of reporter, then maybe I would unit test this thing itself. I do both. I think it's important to do both. In larger projects, I tend to only do integration tests for important parts, because integration tests tend to break for unrelated reasons. And so if you have too many of them, then you're trying to fix your tests all the time. I think it's the metaphor there is the pyramid. So a base layer of lots of unit tests, and then as you go up in abstraction in the test, you get fewer and fewer. Cool.
Yeah, so thanks again. So as long as